Hello, and welcome to Part 3 of the Intro to Epi iPrep series. At this point, we have reviewed fractions and discussed 2x2 tables. In this third series of videos, we are going to discuss some of the different study designs you will learn about in public health. This will help you identify the type of study being performed in any journal article you may have to read. Knowing the study type used will help you decide how valid a study may be. You will also be responsible for identifying studies for homework and exam questions throughout your Intro to Epi course. This first video will review the scientific method. The scientific method is a standardized way for researchers to conduct experiments. It is important for there to be a specific method that all researchers use to perform their studies because it allows for objectivity by reducing bias. It also allows for reproducibility, which means the study can be performed over and over again to confirm or disprove its validity. The steps of the scientific method include making an observation, asking a question, forming a hypothesis, making a prediction, testing your hypothesis, analyzing the results, and using your results to improve your hypothesis and create a new study. Let's go into further detail about each of these. The first step of the scientific method is the basic foundation of all research. It begins when you make an observation. For example, if you notice that people who spend a lot of time in the sun seem to have skin cancer more frequently, you can use that observation to begin a study. The second step in the scientific method is to ask a question based on your observation. For example, does sun exposure increase your risk for skin cancer? Or does using sunscreen decrease your risk for skin cancer? As mentioned in the 2x2 table video series, the big questions in epidemiology involve exposures and potential outcomes. Epidemiologists ask questions about topics such as how diseases are spread or ways to prevent or treat adverse health outcomes. Step 3 is to form a hypothesis or a testable explanation. This educated guess is generally in the form of a statement you can prove or disprove with your research, such as, sun exposure increases the risk of skin cancer, or using sunscreen decreases the risk of skin cancer. Once you have an idea of the relationship you want to explore between an exposure and outcome, you move on to step 4, which involves turning your hypothesis into a prediction. Predictions are often in the form of if-then statements. For example, if people spend more time in the sun, then they will have a higher risk of skin cancer. Or, if people use sunscreen more, they will have a lower risk of getting skin cancer. In step 5, a researcher will design a study to best prove or disprove their hypothesis. There are pros and cons to each type of study design you will learn. Study designs are very important in Intro to Epidemiology, and by the end of the course you will be required to understand how and when they are used. We will introduce a few study designs in the next section. Throughout the study, data is collected and results are analyzed. A researcher will then decide whether to accept or reject the hypothesis. In Intro to Epi, you will learn how to determine the validity of a study based on its design. The final step of the scientific method is essentially going back to step 3, where you will improve your hypothesis, design a new study, and start over based on what you learned. You will notice that most research studies you read about will include limitations and things that could be improved for next time. It is important for studies to be repeated and results to be consistent before something is considered a fact. So to recap, this first video reviewed the basics of the scientific method. We discussed the importance of a standardized method for objectivity and reproducibility. We also went into detail about all of the steps and how the cycle begins again when you reform your hypothesis back at step 3. Please continue to video number 2 for some important terms related to study designs. Thank you.